In how many ways can n objects be arranged in a circular table? So if you could remember the formula that arrangement of n objects in a circular table is given by n minus 1 factorial. But the answer, okay, there is none, but be careful. Let's check something. This, it can be this, it can be this. Okay, let's check. Say, you know, we can write this. If we introduce n, we counter it by multiplying the numerator by n. So we're on the same, they are the same. So from here, you know that this is n factorial over n. So our answer is A. If 15 permutation R is equal to 1, we have to find 15 permutation R plus 1. So there is a formula I'm going to use here that will make the solution to be very, very easy. So as you can, for anything permutation R equal to 1, that is, I'm saying that n permutation R, for it to be equal to 1 means that R is 0. That's R must be 0. N permutation 0 is always 1. So that's the idea we use to solve this. So which implies that this is 15 permutation 0. So R is 0. Therefore, we're asked to find 15 permutation 0. 0 plus 1 is 1. So 15 permutation 1 is just 15. It says that n permutation 1 is always n. So that's, you don't need to waste your time. Our answer is 15. So our answer is D. Answer is D. Let's find the number of ways of selecting 5 out of 10 subjects. 5 out of 10 subjects. This is combination problem. So we have 10 combination 5. Out of 10 we are selecting 5, and we have 10 factorial over 10 minus 5 factorial times 5 factorial, which is 10 factorial over 5 factorial times 5 factorial. Looking at the option, nothing like this, and we cannot just go to D. We can't select D. So we need to do some algebra here. It's not possible for it to be A. Again, I doubt it. So let's check something. Let's bring in, because I'm seeing permutation and permutation here. So I'm going to relate permutation and combination here. There is a formula that states that n combination R over n permutation R is always equal to 1 over R factorial. So with this, which implies that n combination R is now 1 over R factorial times n permutation R. So we can relate it here. N is 10, R is 5. Therefore, 10 combination 5 is equal to 1 over 5 factorial times 10 permutation 5, because R is 5. So as you can see, the answer, and this 5 factorial is 120. So our answer is 10 permutation 5 over 120. So our answer is C. They said in a mathematics competition, candidates are to answer 10 questions out of 13. If the first 7 questions are compulsory, how many ways can each candidate select his or her question? Remember, we have 13 questions. 13 questions. But 7 are compulsory. They are compulsory. So meaning that we are left with 13 minus 7 questions. Are you following? Since 7 are compulsory, we are now left with 13 minus 7 to be selected by the student. So 13 minus 7. Again, since the students are meant to answer 10, but 7 are compulsory, so we are left with 10 minus 7. Do you get this? The total number of question is 13. To answer 10, but 7 are compulsory, so we subtract 7 from each, so we have 6 combination 3. So what we have now is 6 factorial over 6 minus 3 factorial is 3 factorial 3 factorial, which is 6 times 4 times 6 times 5 times 4 times 3 factorial over 3 factorial 3 factorial. So this is 3 factorial gone, 3 factorial. 3 factorial is also 6, so we have 5 times 4. The total orderly arrangement of the word successful is dash. There is one formula that has to do with arrangement of distinct objects. This formula states that the arrangement of n distinct objects such that we have different groups, maybe n1 group, n2 group, n subscript 3 groups, so such that if you add different groups it will give us the total. So we normally, the way to arrange such objects is n factorial over n first groups times the second group times the third group till the last group. Total alphabet, like the group here, we have a total 1 2 3 4 5 6 7 8 9 10, so we have total of 10 alphabets. Inside it we have 1 2 3, x is 3, so we have 3 factorial times u is 2, c is 1 2, c is also 2, e is 1, that's 1 factorial, f is 1, and finally n is 1, l is 1, finally l is 1. So that's the formula we used here. So we have 10 factorial, we just write 3 factorial, 2 factorial and 2 factorial. No need of writing 1 factorial. Again, there is nothing like this in the option. We can't just write none. We need to check whether any of the options, the other ones, satisfy this. So we know that 3 factorial means 3 times 2 times 1, which is 6, and 2 factorial means 2 times 1, which is 2. We can write 2 factorial as 10 minus 8 factorial. We are still correct. So we have 10 factorial over 6 times 2 is 12. This is also 10 minus 8 factorial. So meaning 1 over 12 times 10 factorial over 10 minus 8 factorial. Again, if you could remember, this is written, this is like n factorial over n minus r factorial. So we write this as 10 permutation 8. Definition of permutation. 10 permutation 8 means 10 factorial over 10 minus 8. 10 minus 8 factorial. So our answer is C.